everyone. I will introduce question 1. Question 1a, we need to consider the function y equals to fx equals to 2x power 3 minus 9x power 2 plus 12x minus 4. We need to find the intervals where f is increasing and decreasing. In step 1, we will find the first derivative. The first derivative for 2x power 3 will be 6x power 2. The first derivative for negative 9x power 2 will be negative 18x. For 12x, its derivative will become 12. And for negative 4, it will be negative 0. Therefore, the first derivative for our function x will be 6x power 2 minus 18x plus 12. Let's go to step 2. Identify the critical points. 6x2 minus 18x plus 12 will be equals to 0. After identifying its critical points, we'll get 6x minus 6 times x minus 2. Next, we will take out the 6 from 6x minus 6. Therefore, it will be 6 times x minus 1 times x minus 2. As here, we can get our x, which x will be 1 or x will be 2. In step 3, we need to construct the sign diagram. But let's test our function is it correct or not. For interval negative infinity, 1, we test point 0 and submit into our derivative functions. We will get positive 12 with a behavior of increasing. For interval 1, 2, test point 1.5, we will get the functions is negative 1.5, which show the behavior of decreasing. For interval 2, infinity, test point 3, we will get positive 12, which show the sign of positive and behavior of increasing. Therefore, we can create a sign diagram of x-axis, positive, negative, positive, and 1, 2. In conclusion, for question 1a, the function is increasing of negative infinity, 1, and 2, infinity. And the function is decreasing on 1, 2. For question 1b, the firm face the following demand functions of PQ equals to 100 minus 4Q. And there is 3 sub-questions that will be solved. First, derive the total revenue functions RQ. Determine the congruity of the revenue function. Find the output level at which total revenue is maximized and interpret the result economically. First, derive the total revenue functions RQ. Revenue equals to price times quantity. Therefore, RQ equals to P times Q. P equals to 100 minus 4Q. Therefore, we sub into the formula, we will get the result of RQ equals to 100Q minus 4Q power 2. For question 2, determine the congruity of the revenue function. We need to use the second derivative test. So for the first derivative for RQ, it will be 100 minus 8Q. And the second derivative for RQ will be negative 8. The second derivative for RQ, negative 8, is smaller than 0. In conclusion, since the second derivative is a constant negative value, which is smaller than 0, the revenue function is strictly concave down for all value of Q. This confirms that any stationary point found will be a maximum. Third, find the output level at which total revenue is maximized and interpret the result economically. To find the maximum revenue, we set the first derivative to 0. Therefore, we will get 100 minus 8Q equals to 0, 8Q equals to 100, Q equals to 12.5 units. And we sub it the 12.5 units into the functions. RQ equals to 100Q minus 4Q power 2. And sub into 12.5 units, we will get the revenue of 625. In conclusion, at quantity 12.5 units, the firm maximized total revenues of 625. This occurs where MR equals to 0, meaning producing one more units, no longer increasing revenue.
Hello everyone. Today I would like to explain questions 2A. The total cost for a company is given by the equation TC equal to 100 plus 2Q plus 0.1 Q square, where Q is the quantity of units produced. The first one, calculate the marginal cost for the company. To find the marginal cost, we take the first derivative of total cost with respect to Q, because marginal cost shows the additional cost of producing one more unit. When we differentiate the equation, the constant 100 becomes 0, the derivative of 2Q becomes 2, and the derivative of 0.1 Q square becomes 0.2 Q. So the marginal cost function is MC equal to 2 plus 0.2 Q. Second one, determine if the marginal cost is increasing or decreasing as production increase. We want to know whether marginal cost is increasing or decreasing as production increase. Since the coefficients of Q in the marginal cost function is positive, marginal cost increase as output increase. This means that producing additional units becomes more expensive at higher level of productions, which is common due to factors like capacity limits or inefficiency. That's all from me. Thank you.
Hi, today I will present the solution for question 2 part B. The price function is P equal 100e to the power of negative 0.05q, where P is the price per unit and Q is the quantity sold. Total revenue is defined as price times quantity. So total revenue R of Q is 100q e to the power of negative 0.05q. To find the maximum revenue, we differentiate R of Q using the product rule. The derivative is 100e to the power of negative 0.05q multiplied by 1 minus 0.05q. We then set the derivative equal to 0. Since 100e to the power of negative 0.05q is never 0, we solve 1 minus 0.05q equals to 0. This gives Q equals to 20. So total revenue is maximized when the quantity sold is 20 units. Next, we determine where total revenue is increasing and decreasing. When Q is less than 20, the derivative is positive, so total revenue is increasing. When Q is greater than 20, the derivative is negative, so total revenue is decreasing. Total revenue is increasing from 0 to 20 units and decreasing when the quantity is greater than 20 units. Therefore, the maximum total revenue occurs at Q equals 20.
My name is Damin Chong. My metric number is 312273. I will explain about question 3. Question 3 are given the demand function and average cost function. First, we use the demand function to find the price. Price equal to 45 minus 0.5q. To find the total revenue, we use plus multiply with q, which is quantity. We got the answer 45q minus 0.5q squared equal to total revenue. To find the total cost, we use the average cost multiplied with quantity. So we find the total cost equal to q cubed minus xq squared plus 57q plus 2. Next, we need to find the profit. Profit equal to total revenue minus total cost. So then we find the profit equal to minus q cubed plus 7.5q squared minus 12q minus 2. Next, we use the first derivative and we get the answer minus 3q squared plus 50q minus 12. And next we need divide by 3. We get the answer q squared minus 5q minus 4. And we let it equal to 0. We got q equal to 4 or q equal to 1. So that q equal to 4 is the maximum profit. So question 2 Roman us to use second order condition to prove that the quantity in one Roman result in a maximum profit. So we use the second derivative and we get minus 6q plus 50. And we sub q equal to 4 and q equal to 1 into this. So we got that when q equal to 4, the second derivative equal to negative 19, which is less than 0. And when q equal to 1 in second derivative equal to 9, which is more than 0. So that 4 is the maximum profit.